Welcome. We are finally at the day where we are going to learn how triangles work. This is it. It's been honestly really awkward to teach you guys triangles so far without being able to discuss the triangle angle sum theorem.
Wait,
now,
okay, on this part, are we looking for the area?
No. Well, that we're looking to like find x and stuff. I can help you out with that later, but let's do the notes right now. Okay. Getting started on the notes. Quieten it down for me, please. The triangle angle sum theorem is one of the biggest, most iconic moments of all of geometry. The sum of the measures of the angles of a triangle is 180. That means if you add A plus B plus C, they're all going to add together and equal 180. Now, that is extremely useful. Every angle of a triangle, the interior angles will always add up to make 180 every single time. Like I said, it's been kind of awkward to teach you guys this because a lot of the stuff that we've learned so far, if you know this, you can solve this so easily, right? The interior angles of a triangle are 180. It happens every single time, okay? So we're just going to skip right down to number 1, then we'll go back up to the top. For number 1, I see that this little small angle, follow the arrow, in there is 24. I see that this angle is 37, and there's a big giant angle number 1 that we don't know, okay? We're not talking about vertical angles. We're not talking about corresponding. We're not talking about any of that. But we do know that all 3 of these should add up to make 180. Okay? So, in general, you can do something like, if we call this x, we can do a formula that looks like x plus 37 plus 24 equals 180 because they should all add up to equal 180. But most of the time, the reality is you're going to start with 180 and you're going to take away 37 and you're going to take away 24 and whatever's left is going to give you x, okay? These are literally the same exact equation. All I did was subtract the 37 to the other side, subtract the 24 to the other side. It just makes a little bit more sense. You know, you could kind of do this one in your head, start with 180 and take away the other angles and see what's left over. This one, it just doesn't work as well as far as kind of conceptualizing it. So, if we're trying to solve this question, we're going to want to use Desmos. Playing some games earlier. Either way, x plus 37 plus 24 equals 180. When you type it in like this, you're going to get a function, and you're going to have to zoom out and scroll around and look for the line, and you're going to see 119, which is the answer. 119. Or, again,
for number 1?
For number 1, right. You got 125? The more conceptual, honest math way to do it is to type 180, take away 37, take away 24, and that's what's left. That has to be the other angle. When you type it in like this, you don't have to go looking for the number. You don't have to go looking for the line. It just is going to straight up tell you that's what the number is. Okay? It's super, super useful. Now, then you have the exterior angle theorem, okay? Typically, when we're talking about triangles, we're talking about the interior angles. Exterior angles normally takes kids a little bit of an extra second to kind of wrap their head around, okay? So, what we end up doing is extending one of the lines of the triangle, which, again, kind of takes a second to kind of wrap our head around. It says an exterior angle is formed by extending any one side. An exterior angle is always equal to the sum of the two non-adjacent interior angles. Now that just sounds crazy, geometry nonsense, but the reality is it's saying something that we could eventually figure out, right? So let's look at this, right? If I kind of highlight this with a little yellow, let's say I'm going to put the letter X on the inside here, okay? And then let's say that I'm going to highlight this, and let's say I'm going to put the letter Y here, okay? Now, let's look at just the triangles and the letter X. What do we know about all three of these angles? They all equal to 180, right? And if 2 and 3, let's just say that they add up to make 100, what is the X going to be? 80, right. Okay, they're just going to add up to make 180. Now, let's look at this, the X and the Y. What do we know about these two angles? They add up to 180. They're linear pairs. You guys see how they're linear pairs? We already know about this. And so if X happened to be 80, what would Y be? 100. So that's just us proving everything it says. All right, it says that this exterior angle is equal to the other interior angles, not the one right next to it, but the other two added together. Okay? So, again, if I just was going to make something up, let's say I was going to say that this was 30 and that this was 30. Okay? These two being 30, that's going to add together to make 60. So what is our X value going to be? 120. Now, awesome. It's 120. We know that because it all adds up to 180. Okay? If X happens to be 120 that we just figured out, what is the Y value going to be? 60, because they're linear angles. So the exterior angle and the other two interior angles all these other two add together to make the other angle. So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Now, again, it's one of those things that kind of makes you go, what? Right? It's not that interesting of a theorem. It's kind of trying to help us skip a step. Okay? So, let's do number 2. All right? And let's do it without the exterior angle theorem. All right? So, let's ignore the exterior angle theorem. Let's use all the stuff that we know so far. First of all, if I want to find X, if I want to find this interior angle, I know that all three of these add up to make 180, right? You know what I'm saying? Okay, so I'm going to take all three of these and say they all add up to 180. That means that if I do 180 and I take away 76 and I take away 52, that is the angle on the inside, 52. So this angle right here is 52. Okay? Now, let's use our knowledge of linear angles. Let's ignore the triangle and just think about this. How do these two angles work together? They're adjacent, and I love the word supplementary. And what does that mean? It means they add up to make 180. So how can we figure out the measure of angle 1? Exactly. 180 minus 52 is 128. Okay? Now, we didn't use the exterior angle theorem at all. That was using our angle sum theorem and our knowledge of linear angles. Now, what the exterior angle theorem is trying to get you to understand is that instead of doing all that, take away these two angles from 180. Find this angle. Then take that angle also away from 180. If we just add up 76 plus 52, what do you get? 76 plus 52. You get 128. Okay, so all that kind of slow workaround where we, again, subtracted those from 180 and got this number, and then we subtracted that number from 180 and we got 128. If you just add up the other two, you're good to go. Okay? All right. Question 3. Speeding it up. Are we talking about all interior angles, or are we including an exterior angle? We're including an exterior angle. And the way that this works is that the exterior angle, again, if I kind of write the formula like this, the exterior angle is equal to interior plus interior. Okay? As long as, we're talking about these other interior angles. We can't be talking about the one that's right next to 104. We can't be talking about the one that's adjacent to 104. Let's talk about the other ones. So, using this little formula here, I'm going to put 104 in the exterior position. I'm going to put 79 in the interior position. And angle 1, I don't know what it is. I can put X in this position. And when I set it up like that, you can either type this in Desmos and just make Desmos solve it for you. This is also the easiest equation of all time. How can we isolate X? Subtract that 79 to the other side, however you want to do it. The 1 is angle 1. It's not a number 1, so that's why I used X, because we don't know what number 1 is. So you could type in like this. 104 equals 79 plus X. You could look around for it. There it is, 25. Or you could just say 104 minus 79, what's that? Or minus 79, sorry, it's 25. Okay? A couple different ways to think about it. Bottom line is, it's 25. Okay, we can see that we're starting to get some complicated little pictures here. We got to keep our mind around all these things. I like to kind of pick an angle that I can go for. I think that, angle 1 is pretty easy to get. I think angle 3 is pretty easy to get. I think angle 2, we can't really get that one yet. So what do you want to go for first? Okay, if we go for angle 1, can I set up an interior angle or an exterior angle type question? I'm looking at this and I see that I have an interior, 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 where angle 1 is missing. And so what are we going to do to find angle 1 in Desmos? 180 minus 66 minus 84. And so angle 1 is 30. All right.
What did that say? 180 minus
180 minus 66 minus 84. Because what we were doing is we're working in this small little triangle here, and we were deciding that all the angles add up to 180. Okay? Are we doing okay with that? Again, that is not all that bad. Okay? Now, we could go to try to find angle 2. We could go to try to find angle 3. I don't know that I really want to go find angle 2 next. I like angle 3 a lot more. Okay? There's 2 ways that we know how to find angle 3. We could use the exterior angle theorem, because angle 3, if I think about my triangle, extending the line, this would be an exterior angle. Or I could use my linear angle knowledge, or linear pair knowledge, I should say. I know that 84 degrees and angle 3 are linear pairs. I can find them that way. So, using our knowledge of linear pairs, 84 and angle 3 should add up to make 180. 180, take away 84, 96. Think that angle 3 is going to be 96. What did you say? Exactly. That's exactly how we're going to find angle 2. Yeah. So in order to find angle 3, I was thinking about this relationship, which is a linear pair. They're right next to each other. They're on a flat line. That means they're going to add up to make 180. So I did 180 minus 84. It tells me what's left. Now the other way we could have found angle 3 is using the exterior angle theorem. And I know that it's scaring you a little bit. All right? Either you're not paying attention or it's scaring you a little bit probably. This is an easy like little theorem to use. If you want to find angle 3, all you got to do is add up 66 plus 30. What's 66 plus 30? 96. That's how easy you can do that one in your head a lot of the time. So I know that this is like a lot of words. I know it's a little bit of a scary picture because you have this line coming off. Once you kind of take your time, you can wrap your head around it. You can do it. So now that we have every number except, or every angle except for angle 2, how do you want to go for finding this one? For sure, we want to use the angle sum theorem. We want to say that all 3 of these add up to 180. Anybody find it? Measure of angle 2? You said 41? Looks pretty good to me. Okay. What formula did you use to find that? You did 180 minus
84.
Not 84, minus 96 minus 43.
96.
Yeah.
I did 180 minus 139.
Yeah. Now, let's say you get to the end and you're like, Mr. Collier, I got these numbers. I don't know if I'm right. It's not feeling good. I don't feel confident. Guess what you can do? Add up all the numbers in the triangle and make sure you get 180, right? Add up all the numbers in the triangle and make sure you get 180. It should work like that, right? That's the main law of the day. All right. I'm going to go with number 5. I'm going to speed up a lot. So here we go. Number 5, I see we have a square in the corner. What does that mean? 90. I'm going to write that down. The next easy one for me to go for is angle 1. And I'm going to add up these two, and I know that this third one is going to make 180. So I'm going to start with my full triangle, which is 180. I'm going to take away 90, and I'm going to take away 43. That's going to tell me angle 1, 47. Nice job, heard you. You got it. 47. Now I have this top one, which is 12 degrees. I'm going to have to break in here to get either angle 2 or angle 3. Angle 3 is a long way off. I'm not going to get angle 3 next. I'm going to go for angle 2. There's 2 ways that you know how to do this. You know how to use linear pairs and just do 180 minus 43. But also the exterior angle theorem is not that bad. You literally just add up the 2 opposite angles. So for angle 2, I'm going to add up 90 and 47. That's all I got to do. 90 plus 47.
All right, what you got to do? I want to see that.
So look, here's angle 2. Okay? That is the exterior angle. It is just like this. It's in the Y position. It is outside the triangle. Since it's outside of the triangle, right? So here, look at the orange triangle. Angle 2 is outside the orange triangle, right? Since it's outside this orange triangle, if I add up the 2 opposite angles, that's the measure of angle 2. And so, the measure of angle 2, 90 plus 47, 137. Exactly the same way that you could get, you know, if you did your linear pairs, 180 minus 43, you're going to get the same thing. And then lastly, number 3, honestly, you got to get number 3 right every single time, okay? We know that this is 137. We know that this is 12. How do we find angle 3? Subtract. You start with 180, you start with the full triangle. Take away the 12, take away the 137. What do you got, Jason? 31, perfect. You got this, man, you got this. All right, we're going to do 7. We're going to skip 6. Again, I'm going a little bit faster. I see that in the corner here I have a 90. But which number is 90 None of them, right? Because angle 2 is the top part of the 90, angle 3 is the bottom part of the 90, so none of these answers are going to be exactly 90. I do get the information here that BC is bisecting ACD. That means that when I'm working with ACD, BC is bisecting it. And what does that mean? Cutting it in half. And what is the value of ACD? 90, right? You see the square in the corner? So ACD is 90. And this BC is chopping that in half. I hear it, Kevin. You're right. It's going to be 45 and 45. Because in this corner, we have a 90-degree angle. BC is said to chop that angle in half. And so the top is 45 and the bottom is 45. Because we did 90 divided by 2. You see this 9? You see this? You see the square in the corner? That means 90. The words up here say 90. Like this. Look, this is 90. Bisect means divide by 2. So we just did 90 divided by 2, 45s. From here, we're getting these right every single time. Okay? Every single time. They add up to make 180 in both of these triangles. You want to work on number 1 or number 4 first? If we do the top triangle, if we do 1, we start with 180. What are we going to do? Subtract. Subtract. What'd you get? You don't know? You want me to do it? 52. It ain't 52.
Well, number 4 is 52.
Okay. Oh, sorry. 48 minus 45 is 87 for angle 1. If we go down to the bottom triangle and we take away 45 and we take away 83, there's my 52.
For angle 1, wouldn't it be 180 minus 28 minus 45?
Perfect. That's exactly right. That was 87. All right, flip over to the back. Again, we're not going to do all these questions. No way. But you can see with only this little bit of information, we are able to figure out all of these complicated pictures. Now, look at these pictures, realize, wow, those are some crazy looking graphs. But then also think for a second, with only 2 simple rules, we're able to totally solve these kind of shapes and angles and triangles. All right? The thing about triangles is that even if you have just a little bit of information, you can probably figure out all of the degrees because they all add up to make 180 and things like that. I want to look at number 9, and then we're going to go to the bottom. Okay? Not going to do any of these other crazy ones. Because angle 9 reminds me of transversals, right? It says at the top, L parallel M, right? If I put these little lines on here, that means that L and M are parallel. This reminds me of transversals from the last test. This reminds me of alternate interior, alternate exterior, corresponding, all that kind of stuff. Okay? Now we have even more information now, because now we understand triangles. Now we understand that all angles of a triangle will add up to make 180. Okay? And with that, we can expand this and make a lot of progress and see what we got. So, angle 1, 2, 3, 4, 5. 5 different options. Can anybody have any idea how to go for one of these numbers in particular? I think that 3 and 4 are good options. I think they're both good options. So Leslie, you said 3 first. How are you going to find 3? How are you going to find 3, Leslie? What do you got? Yes, well, 180 minus 73 just to avoid getting a negative number. You're right. Angle 3 and 73 are linear pairs. Mr. Collier, A1. Hello, you're coming back to teach today. Mm-hmm. Mm-hmm. Yeah, so she was very much paired up. We just moved seats, and because it was test or due yesterday and test today, I wasn't really, if the seats were random, I wasn't really worried about like pairing her up because it was test day. So she sits like almost right next to the girl still. So I'm just gonna move her one seat forward, she'll sit next to her again, and we'll be good. Of course. Right. All right. Sorry about the interruption. Different class. I agree completely with what Leslie was saying. She was saying that angle 3 and 73 degrees are a nice linear pair. These two are going to add up to make 180. We did 180 minus 73, and I hope that you got 107. Is that right? Perfect. 107. All right, sweet. We've got 107. We've got another angle figured out. Another person suggested angle 4, which is also one that we can figure out using last unit. Angle 4 has a relationship with this 49 degrees here. What is the relationship between angle 4 and the 49 degrees? So if I extend this line, it might become a little bit more obvious, right? If I think about these two, they're alternate interiors. And alternate interiors are congruent. So angle 4 is going to be 49. Again, that's from last unit. What did you say? Yeah, 5. Yeah, sure, we can go right for angle 5. I agree with you. Angle 5 is a linear pair with 49 degrees, which means we can do 180 minus 49. What do you get from that? 131. I agree with you, right? And look, we're slowly just building this information. Now, here's where there's still another thing we can use from last unit, but let's use something from this unit, okay? Let's find angle 2 next, all right? Last unit, we would not have known how to find angle 2. This is where, as a teacher, sometimes I was thinking, hey, let's go find angle 2. That's easy, but I forgot you guys hadn't learned this part yet. How can we find angle 2 very easily? Right, look at this middle triangle and add all of these up, and they should all add up to 180. So we can start with 180 and we can subtract those and get it from there. You got to figure it out? All right, so he says that angle 2 should be 58. Is that what you got? Did you type 180 minus 73 minus 49 and you got 58? Perfect. 58. And lastly, we have angle 1. There's a couple different ways we could go for angle 1. We can't quite do 180 minus 58 because 58 and angle 1 are not on a flat line. Like you see that, you see 58 and 1. They're not on like a flat, not because 49 is a part of it there. And then this little piece of the pie up here. So I don't like 180 minus 58. What were you saying? I don't know about the exterior angle theorem either, because if we take this triangle, right, this middle triangle, I color it orange, And if we extend the line of this triangle, it either goes this direction, and that's not angle 1, or it goes this direction, and again, angle 1, there's that little piece of the pie unaccounted for. So we actually can't use the exterior angle theorem. Okay? We have a couple options here. We can say that all 3 of these pie pieces should add up to make 180, because all 3 of these pie pieces are making a nice flat line. Or we could use transversals, and we could say that 107 and angle 1 are consecutive interior angles. Right? Parallel, parallel, they're consecutive, same side, interior angles. Okay, so we could say angle 1 is 180 minus that, and we could go with 73. We could also look at the relationship even between angle 1 and angle 73, and we could say that those are alternate interior angles, and those are congruent. Okay, we're kind of slipping away a little bit. One last thing, just to kind of mention the exterior angle theorem. All right, the exterior angle theorem says that if you have a triangle, and we do, we have a triangle right here. I'll use blue. Here's our triangle. That if we extend these lines, and we talk about an angle in this corner, like 131, that it should be equal to the opposite interior angles added together. So the 131 should be equal to 73 plus 58. Is that true? 73 plus 58, yes. Okay? It could also be used, just to double check, that 107 is the same as 58 plus 49. Go to Desmos. 58 plus 49, 107. Okay, so that exterior angle theorem, I know it's got a big scary name. I know it's feeling a little bit complicated. It's not all that bad. I know I got a whole lot of crazy stuff going on in the picture, and I apologize for that. Okay, moving down. Number 12, we're going to do, I don't know, 2 of these questions. Now, yesterday we did where we had the algebra, and the algebra was representing the sides, right? And our strategy yesterday was, if this side is equal to this side, then literally just put an equal sign in the middle. Now that's not the case today. Now this algebra is on the angles. And our main strategy for the angles is that all of these add up to make 180. And so what we're going to do, you know, we got DEF, is we're just going to do D plus E plus F equals 180. We're just going to add them all up and get 180. So, angle D, 5x plus 2. And we're going to add angle E, 9x plus 3. And we're going to add angle F, which is 11x minus 21. And all 3 of those are equal to 180. We got a little bit of typing in Desmos, but I mean, Desmos is solving all this for you. You know, just again, imagine those poor kids before that had to do all this by hand. What a shame. 5x plus 2 plus 9x plus 3 plus 11x minus 21 equals 180. Double check it. 5x plus 2, 9x plus 3, 11x minus 21. Look on your graph. Oof, kind of gross. Is that what you got, Miss Bass? You get a decimal for this one. 5x plus 2. We're on 12. I know you were doing all of them.
I didn't get a decimal.
Did I write it down? Oh, I did plus 2 when it should have been minus 2. Look at that. Always got to check what you're writing down. You get a decimal. You double check it. Little mistake. All right, good catch. Change the plus to a minus. Nice. Sorry, Jazzy. Sorry to pick you out. There we go. X is equal to 8. I was really hoping that that was not going to be a decimal, so I'm glad. We get the 8 as our X value. Now, we still have 3 blanks. We need to find the measure of angle D, the measure of angle E, and the measure of angle F. So let's do them. D is 5x minus 2. E is 9x plus 3. And F is 11x minus 21. I just got those straight off the picture. We just plugged the 8 in. Anybody got any of these angles?
38.
You got E was 38?
No, D was 38.
D was 38, okay.
E is 75.
E, 75. Those do look good.
And F is 67.
And F is 67. And what's a great way to check your answers? Just make sure they all add up to 180, right? If I want to check Kevin's answer, I can say, okay, 38 plus 75 plus 67, they should be 180.
You cold? My hands are cold.
Gotcha. All right, let's do one more. Let's do 15, just so we can see this exterior angle. Then we'll be done. We'll speed it up a little bit. The way that the exterior angle theorem works, all right? We've got K, J, L, and M. All right, we got all the 4 different angles to figure out. Okay? 4 different angles to figure out. If we have these 3 positions, this is looking like the exterior angles, right? Because we've got interior, interior, then we have this opposite exterior. The setup here on the front page, it said A, B, C. If you have it set up like this, A plus B equals C. Those 2 opposites add together, make this exterior. So for our graph here, for our triangle, we're going to have J, which is 5x minus 27. We're going to add that together with K, 7x minus 32. And we're going to equal that to the exterior angle of 9x minus 8. So we're not using 180 for this exterior angles. All right, Desmos is doing the dirty work for us, and I made a mistake last time, so I'm going to double check, because when I make a mistake, I don't want it to lead to 2 different mistakes. 5x minus 27, 5x minus 27. 7x minus 32, 7x minus 32. 9x minus 8, 9x minus 8. Add these up, they should equal that one. All right, I got it written down correctly. Let's get it typed in. 5x minus 27 plus 7x minus 32 equals 9x minus 8. Double check what I typed. Got it? Got it? Got it. And I see 17. I heard a confirmation of that. X equals 17. Fantastic. Now on our paper here, we've got 4 angles that we need to find, which is interesting because we only have 3 kind of highlighted pink information here. Okay? So if I find, let's do the top one first. If I find this top one, if I put a 17 in there, that's the one with K as the middle letter. 7 times 17 minus 32. 7 times 17 minus 32. I got 87. So this whole angle is equal to 87. And if this whole angle is equal to 87, that's the one with K in the middle. That's looking like JKL, because that middle angle was K. 87. Okay, none of the other ones have K in the middle. Now let's go back. Let's do this bottom left one. I'm going to plug a 17 in there. Somebody else figure that one out for me. Anybody got it? 58 does sound pretty good. And that is J in the corner, so I need the angle with J in the middle, which is this top one, 58. Now let's figure out this one. Plug a 17 in there. 9 times 17 minus 8. What did you get with that one? Nice, 145 is right. Now, let's be careful here because we got two options. It's got the L. Both of these options have the L in the middle. Okay, so let's do the top one. KLJ is KLJ. Is that 145? KLJ. No. This looks like an acute angle, guys, right? How is that going to be 145? You see how this is on the exterior of this triangle, not on the interior of it? Okay, so I think that KLJ is not 145. I think that KLM, and if I look over here, that's KLM. That looks better. KLM. That's a big obtuse angle where the inside of it is up top. And so I think that this one at the bottom is 145. Okay? Again, this makes sense using our exterior angle theorem because these two should add up to make 145 if we try them out. What's 87 plus 58? 145. Perfect. Okay? Things are looking great. There's only one thing left. This orange angle here, how are we going to figure that out? We've got all of this information. Okay? If I go on the board here to mark it, I know it'll be hard to see on the video, but over in this corner, oh shoot, I can't remember which one that was. The top one was 87. So we've got 87 here. This one was, what, 58? So this one was 58. And this one out here was 145. How can we figure out this angle in the corner of that triangle? Well, we just add them up and we take away 180, or we start with 180 and we take away these other angles, right? All of this inside of the triangle should all add up to 180. So if I do 180, I take away the 87, I take away the 58, I'm getting 35. All right, that tells me this last one here is 35. Okay, when we're solving these angles, 180 is the big number, okay? We love 180. All the angles of a triangle add up to make 180. However, the formulas are not as easy as yesterday. If you got to add them all up, that means you got to add 3 things together to make 180. Specifically, you got, don't get it wrong. You know, even me kind of rushing through it, I wrote the wrong sign. Okay, so take your time, double check it. If you get a decimal, double check it again. The exterior angle theorem is not as scary as it sounds. The one on the outside is equal to these opposite two added together. Okay, the 87 to 58, you add them, you get the 145. The formula here needs to be you add them together and you get the exterior angle. I imagine that these questions are going to be the ones that really kind of trick you, confuse you. Okay, as far as definitions on the front went, yeah, pretty easy, pretty straightforward, nothing too crazy. Okay, that's it for the notes. Not too bad. All angles of a triangle add up to make 180. Woo!